Welcome everybody. In today's video, we will discuss about sigmoid regression, or you can say it as logistic regression. And our second topic will be hypothesis representation. These topics are very important for your pathway to become a successful machine learning professional. So let's move on. As you all can see, our first topic is sigmoid or logistic regression model. So we always want our h of x to be between 0 and 1, and our h of x is equals to, let's say we take it as a g of function. So here we take it as g of z, where z value is equals to 1 upon 1 minus e to the power minus z. Let me just write it a simpler way, because in this form as a presentation it is hard to understand, but let me show it easier way. So this will be 1 upon 1 minus e to the power 1 minus e to the power minus of z. So this is our g of z. So this is g of z. So now you must be asking, so what's this? That theta, it's the transpose of theta times x. X is our input and theta is our parameter. So we take the transpose of it, since we need to create such a type of matrices that we can multiply them. So let's say the theta will be a singular row and the x will be a singular column. So then we can proceed with the multiplication of matrices. But if both are of, let's say the theta is also column and x is also column, then it will be hard. It will be not possible to multiply them. So there are some rules for the multiplication, so I have taught them in the previous videos of my multiplication and matrices and all. So you can check out and learn if you haven't. So this is equals to z. So this is our z. So our theta transpose x times x is equals to z. Z you can say anyway. And this is 1 upon 1 minus e to the power minus z equals to g of z. So this is our function, and we can also say it as h of x equals to, because both are equal, but you can't say that x equals to z. That will be a wrong way. So now we have written here, we have put the value of z here, and it will become out to be, wait a minute, now our final equation will be 1 upon 1 minus e to the power, sorry, this bracket will be here, and there it will be minus sign there. Sorry, the bracket will be here, not here. That's not a problem, but this shows that the 1 is multiplied by e. Actually it is minus subtracted. That's true. This is wrong. That's a printing error. So anyway, I'm showing you original equation here. That will be minus times theta transpose times x. So this will be the final equation, where h of x can be expressed in the terms of x and theta instead of using z. So let's move on. This is the simpler model, so you can understand it better if you practice it more. We will make a algorithm too, which will we can use to do multiple things like classification or anything else, but that's a part of future videos. So let's move on. First of all, we have to cover the basics so that we will be able to know what is happening. So let's move on. And one important requirement for that, you must know Python, because we will be using TensorFlow and other libraries. So learning the basics and intermediate level will be a great opportunity for those who haven't put their steps into the pathway. So I will recommend using my book. Purchase it from Amazon. That's a very low price, about $1 or 25 cents, $1.25. That's a low price. That's the minimum price, or maybe $2. That's the maximum maybe present. And its value is vary from different country to country. So you can check out the book from the description, and if you like it, you can buy it and learn from there Python, and it will just decrease your time to learn from videos, because they took a lot of time. So I thought it will be easier for you to learn. Now let's proceed. So this is hypothesis representation, our second topic. Now here what we use h of x for, we use it to tell us the probability of getting one output from the twos or multiples. So let's say we want to know what's the probability of getting y equals to 1 with respect to as input x. So first of all, the graph is something like this. It will be something like this, but it will be going through this. Yes, this will be something like this. So this is our hypothesis graph. So it looks like something like this, and the probability of getting y equals to 1 using x as input and parameter as theta is almost negligible here, but we do get 0.99999. Actually getting y equals to 1 and y equals to 0 is, you can say, almost impossible, because this is the straight line, so this will be parallel to x-axis, so this will meet in infinity. So that's a down part, but you can understand that the whenever we get our output y equals to 0.99999, that's a very great output, and getting output in the range of 0.98 or 7 is also a great result. So that depends. If you are developing something like classifier, binary classifier, and you want to detect you send it a dog's image, and or maybe you give it a training set and it performs well, it gives you result of accuracy of 0.999, then it's a great algorithm. I hope you all understood it. So take it as example of cancer. Say y equals to 0 means that the person is free from cancer, and y equals to 1 means that the person has a greater high chance, exactly very great chances to get cancer. So we can use them in the medical field, or we can use them in business fields, and there are a lot of opportunities for machine learning. You can apply it anywhere. So let's say we have a probability of y equals to 0 with respect to x and theta, then we add this with the probability of y equals to 1 with respect to x and theta, so both of them will add up to 1. Since let's say we have y equals to 1 probability as 0.7, then we can easily understood that 70% of the chances are that the person has cancer, and so the chances of the person do not have a cancer will be 0.3, that is 30%. So both add up to 1. So this is a equation. These are mostly used in probability, so you can learn them in your high school or maybe in college. So let's move on. So let's take an example here. Let's say we have x0 and x1. We always take x0. Let's say x equals to this vector. We always take x0 equals to 1, and let's say we use a variable here, maybe, wait a minute, let's say we use a variable q, that's the probability of cancer. So now what we will do is, let's say our hypothesis, we feed this data into our hypothesis, and our h of, wait a minute, h of theta x give us as a output of 0.7. So that tell us that the probability of the patient having cancer is 70%. So we need to take strict actions. We need to admit the patient. So this will help the doctor to examine the patient thoroughly, and if the chances are let's say 0.1, it gives us a value of this. So that shows that doctor do not have to take serious actions. They can be little bit lenient, and they can just give medicines, and the patient can be cured. So that's how this works. So this gives the probability of having cancer. So let's say it as plus, so the 0.3 will represent minus, that the person do not have cancer. So that's how we can use them, and we will learn more when we develop our algorithms for, say, different classification, like we feed it a data of fashion. Let's say we feed it a data of clothes, shoes, and many other items, and we just provide it a picture of a person who is just wearing a pants. So we used to ask from the algorithm that what type of clothes is the person wearing. Let's say we ask him about the data, so the algorithm will reply that the person is wearing a pants. It will store it as a something, some number, and it will return the number, and that will show us that the person is wearing pants. Or it maybe the algorithm returns a picture showing that this person wears this thing. So that's how we can use them, and they are very important because we can use them in multiple industries and get a huge profit, but they require a time and efforts. So before you go on, this is our channel Rindana Coder, and we just reached 159, so we are close to 160. So our goal is to reach 170 or maybe let's say 200 until the end of this month. And I'm sorry for delaying the videos since I have a lot of work this time, so I will try my best to post every week. So with this, let's pause our video and see you later.